What's going on, guys? Real quick video on the plasma table build. Haven't forgotten about it. Just been, other projects, little vacation, friends visiting from out of town, all kinds of stuff. But I've been working on it in the background, a lot of CAD stuff, things like that. Anyway, this thing is a belt-driven gantry. So the gantry, both the X and Y axis, are going to be belt-driven. I'll leave a video link up here where you can kind of see what I did originally with the belt drive. Anyway, it's a tooth belt like this. I think this is a 9mm belt. So I needed to find a way to secure one end of the belt while on the other end be able to add like a tension adjustment. I need to be able to adjust the tension of the belt and make sure that there's no slop in it and everything's working efficiently. So let me kind of bring you in and I'll show you kind of what I've got going on, how I designed this thing, and hopefully it works out the way that I got it kind of pictured in my brain. All right, so for the fixed end, this is what I came up with here. So this is going to slide right into the end of the tube, just like that. And there will be a set screw in the top, and that's all that's really going to hold this in place. I mean, I've made it so that there's really not a whole lot of play in there. There's a lot of space, and this kind of locks it in. So it shouldn't take more than a set screw. If it needs more than that, I'll figure it out. But for now, set screw. So here you can see on the very front, I was able to model. I found the drawing for the belt, like the engineering drawing, and it gave me all the dimensions. So I was able to model the teeth of the belt with some modifications for 3D printing, kind of make some adjustments to it. But I got that printed out. And then you can see there's a hole right there in the bottom. The belt will come in from the back side, come through here, and then it'll come up, lock onto those teeth, and then there's a cover plate that'll go right in place, and that'll lock that end of the belt in place. Then the belt will travel down along the bottom of the table. Here's the motor with the gear. I've got a mount for some rollers, and then it'll go through all the way to the back side where I've got something similar to this that has a belt tensioner built in. Let me kind of get this basically put together, and I'll show you what I mean. So the first thing I want to do is add the set screw to hold this in place. So I'm going to drill and tap a hole for a 1/4-20 tap. So drill the hole. So obviously first thing you want to do, add a little lube, and that will help to protect your drill bit. Anchor lube, best lube you can get. Check them out. I'll leave a link down below. So let me get this out of the way. And drill this hole. All right, next is to tap that hole. So once again, we'll add some lube. Help extend the life of your drill bits, extend the life of your tap. Just make cutting a lot easier. Plus, it'll help kind of hold the chips. Get this hole tapped. And get the set screw started. Yeah. Let me grab it. Let me use a shorter set screw. I just grabbed the first one that I found, and obviously that one was too long. I think I'm gonna have to go to the store and get some shorter ones. This is the shortest one I have, and it's probably gonna be too long. But anyway, it'll work for now. Proof of concept. All right. So there we go. Actually, that's just about perfect. That thing is locked into place. All right, now I'm going to mount the roller on the gantry on the bottom side, and I'll run the belt and kind of show you how that's all going to lock into place. All right, I've got the belt run up kind of through the rollers and through the motor. I'll show you that in just a second. But the end of the belt here just comes up through this hole in the backside, pulls up and locks on to those teeth right there. And then I've got this cover piece where I've got a notch out there for it. Now obviously I don't have all the threaded inserts done yet. This is just a proof of concept. So we can throw that in place. Put in a couple of screws to hold it. I've got all of this is printed out of PETG, so it should be a little bit more sturdy. I mean, I'm not too worried about it. There's really no pressure on any of these. Very little. It's not structural in any way. I mean, this thing is pretty beefy the way that I made it, so it'll sit in there and not move around and be pretty secure. So PLA would probably be fine. So there we go. All right, that's locked into place. But now that belt is secure. I'm moving the whole table. That belt is locked into place. All right, here you can see I've got the roller mount installed onto the gantry. So the belt will come through. Hopefully the shadows aren't too bad and this shows up okay. But that'll come through like this. Then this end comes out that way. And that secures everything on the roller. Now, I am noticing some flex there. So I'm probably going to have to redesign the roller mount here. But what that's going to, for now, that'll be okay. But what that does is now the motor will be able to turn and draw the belt, or turn the belt and move the gantry forward and back. So yeah, but now I gotta show you guys what I did for the tensioner on the other end. For the other end, for the tensioner end, I built another, basically the end block, just like the one that's on the front, except it doesn't have this cutout here for the belt. What it has is this hole right here. You see that? There we go, there's a good angle. It's got that hole there with a small hole on the back side. And what that's for is this little setup right here. All right. So this block, come on, has the same tooth pattern printed into it. All right. And then it's got, so it means that the belt can sit on there. Man, my focus is just all over the place today. That belt can sit on there. And then there's just a little, like a little wedge piece that'll sit right on top. And then it's got a hole in the end with a threaded insert. And what that's for is now this whole thing, well, it actually goes this way, will slide in there. It's snug, and it's got to be to hold everything in place, to hold all this. This whole thing slides in there, just like that. All right? And then the screw comes in from the back side and will thread into that threaded insert. And as you tighten that down, once it makes contact, that'll thread in there. Try to do this where it's not focusing on me. And it'll pull that whole block right in there, tightening that belt down. So let's get this onto the frame and see how it all, make sure it all works the way that I think it's going to. All right, so I've got the belt trimmed down to length, mostly. I mean, I have it set so that it goes basically inside there, maybe a third of the way or so. And then I got the lock piece, just like that. And then the little wedge goes on the bottom. That just takes up the gap. And now the whole thing can go into place. It's a little difficult working around the camera here. I may have to move the camera and bring you guys back once I get this in here. It's just a tight, trying to work around this thing. It's a little snug. All right, let me move the camera and I'll bring you back. All right, so I got everything in place. I ended up having to loosen up the fixed end in order to be able to kind of take this all apart, put it together out here and put it back together. But I've got it all secured in there. So now I can take an Allen wrench, put it on the back side, turn this, and you can see that belt tensioning, tightening down that belt. And I can adjust that as need be to make sure that everything meshes well on the teeth and everything works just the way I intend it to. And I'm noticing that this wedge isn't sliding in there. So what I could do now is I could loosen this up. Like the whole thing is sliding except for the little wedge piece that's not sliding. But I can shove it in there further. There we go. Make sure it's in there. And now when I tighten this down, it'll pull in there and that it'll still be fully seated with that little wedge block in there. You can see it tightens down pretty good. Now I don't know how much tension I'm going to need on this just yet until I can start getting things moving, but yeah, now I have a belt drive. The belt is protected under the frame so that while I'm cutting, I don't have to worry about any sparks or anything like that, which is exactly what I wanted for this setup. I wanted that belt protected under the frame. It's protected from sparks, it's protected from basically everything. And it's fully adjustable. Now, like I said, I may have to look at redesigning the roller mount. I already redesigned it once to beef it up, but it's still flexing more than I would like. I don't know how that's going to affect the overall operation of this thing, probably until I start using it, but I will start looking at maybe redesigning that. So I've got the gantry work, done. Nothing's mounted. As you can see, the bearings are all just kind of hanging out. Nothing's mounted yet. Belt drive is in place. So I think the next one is going to be... So I was just wrapping the video up and I decided to come over here and just kind of move this around for a second to see. And here you can see that's how that's going to work. Let me try to get a better shot down in there. Oops, knocking stuff over. But as you can see, the gantry moves, the motor turns, which should move that belt along, driving the gantry. Nice and smooth, actually. So, yeah, I'm really happy with the way that's turning out. Again, I'll have to look at the flex of this, make sure that doesn't flex too much, doesn't affect the overall operation of it. But so far, it's looking pretty good. Probably the X-axis itself. I got the mount for that. I've got to print the actual mount, or what locks it all together. We'll go from there. Really appreciate you guys for watching. Hit that subscribe, hit the bell, and I'll see you on the next one.